Yeah, this wall clock seems to be stone dead. All right, well, my laptop claims that it's 3 o'clock, so we will begin. You will, on Thursday, during the final exam, be responsible for, everything that we've talked about during the first 6 weeks of the course. Basically, today I'm happy to answer any questions that anybody has about anything. If you don't have much questions about much, then I've put together a quick review in reverse chronological order of things that we've talked about during the class that I expect everyone to know. Does anyone have a question at this point? Yes?
So I had a problem with the homework last night.
Okay.
So I should have well. I couldn't figure out why for the Boolean index when I tried to make my bracket. I tried to make the row column 1 colon 2. It wouldn't accept it.
Okay. Yeah. Some other people asked me about that as well. So let me create myself an ND array really quickly. Or actually, with any luck, hopefully I have this observations file available. Let me see if I can get that. So, wait a minute. I can just say it's gen from text, right? Yes. Cool. I wasn't 100% sure I had it in the correct directory, but I do. Okay. So one of the things that we talked about last time is if you have a two-dimensional ND array, you can access parts of it. You can access all right. You can access a row or a column as a two-dimensional ND array, or you can access it just as a one-dimensional ND array. Now, I think what I think I unintentionally confused some folks with regard to Boolean indexes. If you want to select a particular subset of rows from a two-dimensional ND array using a Boolean index for the rows, the Boolean index itself needs to be a one-dimensional index. So I would need to say something like this. So B index, let's say, is, I know there's 20, well, let me just verify. I'm pretty sure there's 20 rows in this thing, yes. And so I can say something like B index gets, and now I'm going to set up a list for my B index. And since I'm lazy, I'm going to say true, false, times 5, times 10. Okay, so that's going to give me a Boolean index of 10 true-false values. The times 10 here is going to be repetition. So B index, in this case, is a list of true-false values. And so if I say OBS sub B index, I get every other row. I get the odd-numbered rows from my observations. Now, if I want to access the homework had to do with people's heights, is that correct? I'm sorry?
Patient height greater than or equal to 70.
Okay, so if I say OBS sub 1 greater than or equal to 70, all right, this is going to, I'm sorry, that axis is just row number 1. That's not right. I want all rows but column 1. This is going to give me back a one-dimensional vector of true-false values where I have true each time the person's height is greater than or equal to 70 and false otherwise. Now let me just display just the first few rows to convince myself that this is true or that this is correct. OBS colon 7. Okay, so I have false, 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 which is 62.5, 62.5, 65.5, 65. Then I have true and true, which are the 70 and 71.5, and then I have false. So at least for the first 7 rows in the observations list, this is a correct Boolean index. Okay? And this has, this is a one-dimensional Boolean index. And so I can say GE70 gets OBS colon comma 1 greater than or equal to 70. And now I have a reference to that Boolean index. And now I can say OBS sub and use the Boolean index to get just the rows where the person's height is greater than or equal to 70. Now, if you say, and by the way, I don't need to have a variable for the index. I can just use the index directly. I can say OBS sub column 1 greater than or equal to 70. I can just pack it all together like that and I get the same result. But if I say OBS sub colon comma 1 colon 2, that's valid. That's using slice notation to access parts of the OBS two-dimensional ND array. But unfortunately, the result is two-dimensional. So, whoops. Oh, I forgot my test. I apologize. Let me copy and paste that. And have greater than or equal to 70. And I do have Boolean values, but this is a two-dimensional index. It is a 1 by 20 two-dimensional index, and that's not valid to use as a Boolean index. You can't use a two-dimensional. Okay, let me try to be really careful here. If you have a two-dimensional ND array, which we do, then you can use a one-dimensional index to get just certain rows from that two-dimensional set of observations. You can also use a one-dimensional index to get just certain columns from that two-dimensional ND array. But if you have a two-dimensional Boolean index, then the size of the two-dimensional index, the dimensions, the shape of the two-dimensional Boolean index has to be identical to the underlying observations. All right, so here are my observations. I've got 20 rows, 3 columns, if I say something like this, OBS all rows, all columns where well, I don't even need to do that. I can just say OBS greater than or equal to 30. Let's say 40. And OBS less than or equal to 55. Less than or equal to 65. Now, because of precedence, I don't think I've talked about this, so this is something I'm not going to require you to know. But here, since I've given the name of the entire ND array, its equivalent is if I were to say all rows, all columns, and it gets me back a two-dimensional Boolean index that's of exactly the same shape as the one-dimensional index. Let me just do that part. Okay, so now I have a two-dimensional Boolean index where I have true and false everywhere that any value in there is greater than or equal to 40. And because everybody's height is greater than 40 and everybody's weight is greater than 40, the height column is all true and the weight column is all true. It's only the age column that has a mixture of trues and falses. But that index is exactly the same shape. And if I were to combine that with another characteristic, observation of, observations, every row, every column, greater than or equal to 40, and observations, every row, every column, less than or equal to 55, let's say. And as I say, I didn't show you this. This is not something I'm going to expect you to remember, is these binary and or operations. But this gives me back a two-dimensional ND array. Oh, that was more restrictive than I wanted. I got everything false now. Okay, so if a value in the ND array is greater than or equal to 40, and it's also less than or equal to 70, I'm going to get a true. So I'm going to get true now for both heights, both ages and heights, but everybody's weight is greater than 70, so I get falses for all the weights. All right, that was an extended answer, but did that help? Okay, yes? Precisely, yeah. So, so here is my Boolean index. All right, so I'm going to create a Boolean index. I'll call it BIDX2. And if I say OBS sub BIDX2, I just get the values where that relation is true, which displays as a one-dimensional vector of the values where that's true. But if I use that on the left side of an assignment by saying OBS BIDX2 gets 0, let's suppose that I want to just erase all of these values. I want to set to 0 all of these values where some observation is greater than or equal to 40 and less than or equal to 70. And now my observation ND array has been changed. All the values in here that were greater than or equal to 40 and less than or equal to 70 have been set to 0.
So the result will always be a one-dimensional. So can I do something like match the value into to arrays that like the index is true, and if the index is true, and show that the value in that position is another array.
Yes. There may be a faster way to do this, but I can certainly immediately see a way. So let me reread my observations, because I have ruined them now. Okay, so I have refreshed my observations array, ND array, and now, so what you would like is to have a two-dimensional ND array that only shows the values where that test is true. Is that the idea?
Yeah.
If you wouldn't mind, since this is, I mean, I can easily see how I would do this using comprehensions, but this is kind of beyond anything that anybody's going to face on the final. So if you would be so good as to email me this question, I'll answer it by email and I'll post my answer. But I'd like to get back to things that are actually likely to show up on the final. Is that okay? Okay. Other questions? Yeah.
So just playing around with Boolean indexes, I could get it to where I would do like B rows and I could refer to certain rows and then do the same for columns, but when I tried to do both at the same time, I was getting a weird like output.
You were getting probably one-dimensional output.
Yeah.
Yeah. Okay. So here's my observations. Let me shrink this window again so you don't have to look down so low. Here's my observations. Let me just show the first 10 rows. Within those 10 rows, I can show, let's say, the last two columns by saying 1 colon for my column slice. Okay, so there I've got the first 10 rows, the last two columns. And so I think what you probably did was something sort of similar to what I did up here that got you a one-dimensional result.
Yeah, so like earlier you had set up this B index that was returning every other row.
Yeah.
So it'd be like that, but let's say if we wanted every other row, but only the first and third column. When I tried to combine them, usually Python would spit out the first object in the first row and the first column, and then the last object in the last column, and that was it. And everything in between was just hopping out there.
Okay. So if I have my B index, my Boolean index of every other of true, false, true, false. This thing is 20. This index is 20 items long, And so if I use it to index rows, that's going to get me every other row as my result. And then you tried to also do what with columns?
Yeah, so like let's say hypothetically we wanted this, but then also just wanted to look at age and weight, so the first and third column. Like I wasn't sure how to...
So something like 0, 2.
Yeah.
To use fancy indexes?
Yeah.
Yeah, and you get this complaint.
Yeah. Or even if I tried to set up another variable that was like e columns and use like a Boolean index that way, that's still having trouble.
So like this. And then try to do like 0, 2 like this.
Yeah.
Do you remember?
So yeah, this might be a little bit outside of what the fun on my cover, so we can move on, it'll be fine. But it was basically this kind of last example that you showed in the last class, but we had B columns, we had B rows, referring to whatever you wanted to define. When I combined the two, I wasn't able to like get the result that I anticipated. But maybe I'll ignore that one too.
Okay. Yeah. Okay. All right. So yeah. So let's take as a wish here that if you have I'm not going to ask you questions that are this complex. I will ask you questions such as what are found in the notes. I will not ask you questions beyond what are found in the notes. Okay? And sometimes I have been known in the past to ask questions that are a little beyond what we talked about, but I will restrain myself. I will not do that. So anyway, back to anybody else have other questions so far? Good. Okay. So I'll just you can interrupt me at any time and ask me any question that you want, but I'm just going to go through sort of reverse order of things that we talked about. Last Thursday we did introduce a bunch of string operations, and most of them are pretty easy. You should know these things. The two that are maybe a little bit tricky that we talked about are the join method of strings and the find method of strings. And also, another tricky thing that we have taken various runs at over time is the format method of strings. So these are the only ones that I wanted to show examples of. If I have a list of strings, well, I guess I better give that a variable name. ls1 gets I think this is a book, but I've never read the book, so I'm not sure. Okay, so I have a list containing 5 strings, a place in the sun, and if I say space dot join the items in the list, those strings in the list are joined together to create a single string, in this case separated by spaces. And the join string can be anything so this is not terribly readable, but it works. I have ASDF, ASDF, place, ASDF, ASDF, etc. And the tricky thing about join is that it seems backwards from what you would want to do. It seems like you should want to say ls1.join with spaces, but that's not correct. Okay, so join is a method of the string class, not a method of the list class or the tuple class or the set class. So you have to have your string first, and then your join, and then your iterable, in my case ls1, of the strings that you want to join together. Okay? Now, formatting output in a clean way is a very important thing to be able to do. This is not something that you want to have to look up every time you need to produce formatted output. It is worth just committing to memory and practicing this stuff to make sure that you can do this, you know, at will, instantaneously, in any circumstance. As I've said, there are 4 different generations, 4 different variations on how you can format data into a string. You know, we could probably have several weeks of discussion about all these variations, but the particular one that solves almost all problems is the one where you have a format string consisting of curly brace colon notations and field widths and value type specifiers. So here I'm going to print a string in a field 10 characters wide that's centered, or a base 10 integer, a decimal integer in a field that's 10 characters wide, left justified, or a 10 character wide with 2 characters after the decimal place, right justified, fixed point value. Okay, and if you just get used to that pattern, you know, curly brace colon, justification mark, width, and then for a floating point, you also can specify a precision, and then the letters, S for string, D for decimal, integer, F for fixed point. You're all set. You can handle most situations. Questions? Okay, and then find gives you back an index of where the beginning of some string that you specify as an argument exists within the string that is the object that find is being applied to. Find actually takes, as optional arguments, you can specify a starting position, a starting index, you can specify an ending index, and you can also specify a step index. But we didn't talk about those extra arguments, so we'll just leave it there. Everybody happy with strings? Any questions? Okay. NumPy, we have spent some time talking about. You should make sure that you understand the examples that are in the notes about accessing individual items, accessing entire rows or columns, and then the 3 different indexing mechanisms: slicing, Boolean indexes, and so-called fancy indexes. Yeah?
Yeah, okay, great. So I'm just wondering, just quickly with strings, can you give an example of like a type of data set that we would load in that would be filled with strings? Is it something like what we saw? I'm just thinking like for application's sake.
Yeah, okay, good. Nowadays, actually, almost everything that you load in is going to be originally come in as strings.
Even numbers?
Yeah, even numbers. Now, in olden times, it was common to have binary data, numerical binary data stored on local files on your system, and you needed to know, and you still do, I mean, Well, I mean, let's admit it. There's another semester and a half's worth of stuff that you really need to know. But we're, we're starting out here. And so, yeah, you should know how to read in bytes from a local file and things like that. But nowadays, where we live in database land and web land, stuff that you get from a database, stuff that you download from the web in various ways, XML files, HTML files, CSV files, all of these things are, most of these things are text that you pull in, and then if you need to treat those values as integers or floating point numbers, you have to convert them. Other questions? Okay. All right, we looked at comprehensions, and I said that this was a really Pythonic thing to do. Basically, the notation for a simple comprehension, now we can add complexity to this, but we're just doing simple ones. If you want to comprehend a list, then you have some expression at the beginning of the list inside square brackets. Typically, that's just like the name of a variable, or perhaps even a constant, or some variable times a number, or something like that. And then you have your variable stepping through all of the values in some kind of iterable. That iterable might be a range, that iterable might be a list or a set or a tuple or the keys in a dictionary, or whatever it might be. For example, ls2 is just plain I for I in range 10, 15. Okay, so the range, I can specify where to start, and I can specify one pass where to end. So this is going to give me a list containing 10, 11, 12, 13, 14. Or I can be more sophisticated than that, and I can create a list of tuples by having my expression at the beginning be a tuple 0 I to the, well, I to the I, oh no, I to the I will work fine. I was going to say I to I will be a problem for 0, but I don't have 0 in my range, so this is good. All right, so now ls3, 0, 10, 10 to the 10th, 0, 11, 11 to the 11th, and so on. Yeah?
Sorry. So on the quiz, there was a question about printing something in descending order. Can you show us how to do that? Gotta flip the range around.
Okay. Have we talked about the step size for the range function? Did we? Okay. There's various ways of doing it, but let me show that way. So I could say start from 14 and go down to, but not including 9, with a step size of -1. I can do a similar kind of thing for a for loop. Otherwise, oh, I just destroyed my ls3. Well, that's okay. Otherwise, if you've got stuff on a list, you can just reverse the list, and then that will get you descending order instead of, well, instead of whatever order you had. Other questions so far? I'm sorry?
What do you mean by reversing the list?
Maybe I didn't show you this one, but ls1 is a list of these guys, ls1 dot. I will not test you on anything that's not in the notes. I'm very careful whenever I put the exam together to look at what's in the notes, not what's in my pitiful little brain. Okay. But there is a reverse method for lists that simply reverses the order of the items that are in a list. And there's also a sort method for lists that puts the list items in technically non-descending order, but you can just think of it as ascending order. Okay? Yes?
The reverse order in the, in the step one, so we can refer to -1. So can we refer to -2?
Oh, maybe that's what you meant by reversing. Yeah, I'd forgotten that. Yes. Yes, we can certainly, okay. S gets, this is some stuff. ls4 gets a list built from S. And so now I have a list of 1 character wide strings by using the list conversion function. And yes, ls4 sub -1 is the last item in the list. ls4 sub, well, 0 is the first item. But I can say for S in, for I in range 0, 1 up to the length of ls4 plus 1, print S sub minus I with a separator of space. All right, so that's another way of reversing things, is to just use integer indexes that are counting downward rather than upward. So this is going to give me -1 first, and then -2, -3, and it's going to count downward through those list items. I made a mistake there. I didn't mean sep, I meant end. We've talked about sep and end, have we not? Okay. All right, so here is... All right, so here is ls4, which is those string values in the order that they exist within S. One substring at a time, and here is how I can loop through. Here's a different way I can loop through and get those things in reverse order. Although I've lost my quotes. Questions? Anything else about comprehensions? Okay, so list comprehensions is the thing to get really comfortable with, and then set comprehensions and dict comprehensions are easy because a set comprehension is exactly like a list comprehension except you use curly braces. A dict comprehension is just a tiny bit, just an ever so tiny bit more difficult in that you have to have a key and a value for each entry in the dictionary. And k comma v is one way of setting that up. Okay? All right, well, we looked at conversions. You can convert just about any kind of iterable into a list or a tuple or a set or a dictionary. But in the case of a dictionary, the iterable has to be over pairs of values. The official documentation talks about an iterable on 2 tuples, but it can actually be an iterable on 2 lists or 2 sets or any kind of pairs. And one way to create pairs, if you have 2 separate iterables, is to zip those 2 iterables together, and then you can use the result of zip to create your dictionary. which is actually pretty common because very often you have two separate iterables that happen to have the same number of values in them. And if you want one of those iterables to be your keys and the other iterable to be your values, you just zip those things together and give it to the dictionary conversion function, and you're good to go. Questions? All right. Okay, a large program, even a medium-sized program, is typically split into separate modules of code. You want to have code that's all related to itself in a module. Very commonly, you'll have some kind of data structure, some kind of table structure that you have a collection of interfaces to talk to, or perhaps something like a class, which we didn't get into in this course. And all of that related stuff that manages that data structure or that table or that class should be in a module. And then in your program that you're writing that's using that facility, you have an import statement. I should have had import on my on this slide, actually. So remember that you need to know about importing things. And within the module, you can detect what the name of the current module is with the dunder name variable. And in particular, if dunder name is equal to the string dunder main, that means that you are currently executing the module. That means that this is the module you are currently editing, currently working on. And it's common to put test code underneath this if dunder name is equal to dunder main statement, or if test. Questions? All right. We took a look at, we spent a lecture talking about how to create, access, modify, and delete items from the various collection types. We talked about how to create empty things, single item things, multi-item things. And the only tricky ones to remember there are that an empty set is set open close parentheses. Empty curly braces is a dictionary. And in one of my other classes, I've got tons of people using empty curly braces to create a set on their quizzes, and it doesn't work. So remember that to create an empty set is set and parentheses. Curly braces by themselves are an empty dictionary. Similarly, an empty tuple is just open and close paren, but open paren, 5 close paren is not a tuple. That's just the integer value 5 protected from its surroundings by a pair of precedence overriding parentheses. So to get a one-item tuple, you need to remember this silly notation of putting a comma after the value. Okay, and then there's a bunch of terminology that you should be well acquainted with, like which of these things are mutable, which of these things are immutable, which of these things are sequences and therefore can be sliced, which ones are sortable, hint, list. And which of these require hashable items. And here the short answer is items in a set have to be hashable, and keys within a dictionary have to be hashable. I did not fully describe, in ponderous technical detail what hashable means, but for our purposes, all of the base data types are hashable. That is, int, float, stir, bool, and the value none are all hashable because they can be told apart from each other very easily, and they have unique values. And tuples are also hashable, assuming that the things they contain are hashable. All the other collection types, namely list, set, and dict, are not hashable. Because among other things, they are mutable. You can change what they contain, and therefore they do not have fixed so-called hash values. And we also talked about how to go about deleting items from these various collections when that's possible. Now, a stir and a tuple, those are both immutable, so you cannot directly delete items from a stir or a tuple. Although it's so easy to just create a new stir that doesn't contain the character you want to get rid of that it's almost, in terms of writing actual code, it's kind of almost a non-issue. Questions? All right, so in the relevant lecture, just make sure that you understand what's in those various tables and the descriptions. Yeah?
So is the set hashable?
The set itself is not hashable because you can add and remove items in the set. So a set can only contain hashable items, but a set is mutable, therefore a set cannot contain a set. And likewise, a key for a dictionary cannot be a set. A list can contain a set because there's no rules imposed on values that you store in sets, or for that matter, values that you store in tuples or values that you store in dictionaries. But set items and dictionary keys have to be hashable. Pardon me? Well, a tuple is conditionally hashable. A tuple can contain anything. So a tuple can contain a low-level scalar type items like int, float, bool, stir. A tuple can also contain a set, or a dict, or a list, or some combination of those. But if a tuple contains one of those mutable items, then the tuple itself is no longer hashable. So in order to qualify as hashable, the only thing that you can have in the tuple are other hashable items. Let me just show a really simple example. I can say, create a set containing the tuple 1, 2, the tuple 1, 3, the tuple 2, 5, and that's, oh, well, that would have been fine if I hadn't typed a square bracket at the end of it all. So let me just try that again. Okay, so there I have a set of tuples. But if I say curly brace, okay, I've had one of these embarrassing moments where I've forgotten what I was trying to show you. Okay, so if I have a set of tuples where one of the items in the tuple is a list, let's say, then this won't work. All right, so I have a tuple that contains an int, a list of int, and an int. Now the tuple is okay, but the set is going to complain that this thing inside the tuple is not hashable, and therefore that set is not allowed to be created. Good? Other question? Or any other questions so far? Okay. Okay, now, so the conversion functions you should know about, list, tuple, set, dict. You should also know about the various symbolic and named operations that these different collection types provide. And they're, these are described in the notes, so I won't just read this long laundry list to you. You should know that plus for Lists and tuples and strs means concatenation. Times means repetition. You can ask for the length of any of these collection types. Now, you can append values to a list. You can add values to a set. But you can neither append nor add values to a tuple, etc. Questions? Okay, we took a look at dealing with user input, which also forced us to talk about the idea of exceptions and how to, one simple way of handling exceptions. The input function optionally takes a string as an argument, and that string is displayed as a prompt to the user. The input function will cause the program to wait until the user has typed a line of input and hit the enter key. And when the user hits the enter key, the line of text that the user typed will be read in, and then we'll have this variable s, whatever it is, referring to that string that the user typed. Often we need to convert that thing the user typed into a floating point number or an integer, and that conversion, unfortunately, may fail because users are users, and they don't always do what we want. And so if a conversion fails, that will raise an exception, and then you can use the except keyword, the except block, to do something about that. We also took a look at defining functions. You say def and then the function name, and the parentheses and the colon here are required. The function may or may not also expect to receive parameters of various kinds. Now, I don't believe that we looked at defining a function to receive a keyword parameter. Did we? Okay. But we did see, for example, the print function that does have a keyword parameter, a couple of keyword parameters like sep Okay, so that's an example. Sep is an example of a keyword parameter that the print function takes. We simply didn't get into the rules of how to go about setting that up ourselves. So you don't need to know how to use keyword parameters in function definitions. Very often, a function will return a value, specifically return a reference to an object. That's not required, but it is usually the case. Be careful if you are asked by me or by your boss or by your colleague to define a function that returns a certain value. That means that it has to have a return statement in it. Displaying the value with print is not valid. If the function is supposed to return a value, it's got to have a return statement in it that gives that value back to whoever called the function. Everybody good? Okay. Okay, so we took a look at two different kinds of loops, namely the while loop and the for loop. We also introduced the range iterable that allows you to step through sequences of integer values. We introduced the if, elif, else decision. Now, in a decision, you have to have one if. If you don't have one if, you don't have a decision. And you're only allowed in that same decision to have one if. You can't have two ifs in an if. All right? Although you could have an if contained within another if as a sub phrase. You're allowed to have optionally any number of elif parts, and you're also allowed to have optionally exactly one else. And the order of these matters. The if has to be first, the elifs, if there are any, have to come next, and the else, if there is one, has to come last. let me show you what I mean by an if containing an if. I probably should have just kept my mouth shut about that. But let's say I have s gets input, enter a letter. Now, I'm just asking the user to enter a letter, so I don't have to convert anything. I don't have to worry about exceptions due to conversions. I can say if s is equal to a, or s is equal to e. All right, now I'm going to get tired of this pretty quickly. I'm trying to test whether this is a lowercase vowel. Let me show you. I'm sorry? Bingo, yes. So a much simpler way to do this is to say if s in a, e, I, o, u. Now, I should probably ask whether the length of s is equal to 1. Okay, so if the length of s is equal to 1 and s is in that, somewhere in that string, that collection, a, e, I, or u, now within here I can say print s is a lowercase vowel. Okay, and then I can say elif len s equals 1 and s in a, e, I, o, u s is an uppercase vowel. Else print s is not a vowel. All right, so there's a minimal example of an if, elif, else kind of decision structure. Let me save this with some random name. I'm going to just call this thing foo and run it. And always and forever. I forget that colon on the else. Never have any problem with the if or the elif, but always on the else. Enter a letter. So Q. Q is not a vowel. Enter a letter. A. A is an uppercase vowel, and so forth. Now, you can, within the if, have a nested if. You can say if s equals a, print s is lowercase a. And that's not going to work, so what do I do to fix that? I can use double quotes to turn off the special meaning of the single quotes. Okay, so there I have an if nested inside of an if, and that's perfectly valid because I've got the indentation to show how that's supposed to be done. Enter a letter, A. A is a lowercase vowel, A is lowercase a. Okay, so everybody cool with the if, elif, else business? All right. We also talked about the idea that objects have identity associated with them, and this even includes individual values, like 123 has an identity associated with it, and 4.7 has an identity associated with it. You can use the ID function to get the actual identity. More commonly, you just want to know whether two different variables refer to the same object. And you can do the if x is y or if x is not y to detect whether two variables do or don't refer to the same object. Everybody happy? Okay, now here is the table in descending precedence order of the equality, relational, identity, and membership tests. Those all have the same precedence. And then below those, we have the logical operators, not, and or, in descending precedence. So this is something that you should, this is one of these annoying things that you really just should commit to memory so that you don't have to be debugging code because you didn't remember the rules, or you don't have to be looking this stuff up in a book all the time. These are the operators. They're not going to change. Just make yourself know this stuff and you'll be good. Similarly, the same thing can be said for the arithmetic operators. We have the exponentiation operator is the highest precedence, and it associates from right to left, which is unlike the other binary arithmetic operators. Plus and minus are potentially a little confusing because we have both unary versions, which have precedence just below exponentiation, and we also have binary versions which have the lowest precedence of the arithmetic operators. And then at the multiplicative level, that's the third level of precedence, addition, division, floor division, and modulus all have the same level of precedence as each other. Now, these rules are intended to make intuitive sense, although exponentiation may throw off the intuition here. But you are accustomed to thinking that 5 plus 3 times 2 plus 1 is going to be 5 plus 3 times 2 plus 1, right? You just assume from your own training in younger years that multiplication happens before addition. So this is going to give me 5 plus 6 plus 1 is a 12. I can use parentheses to override the usual precedence to get 8 times 3 is 24. Okay, now as far as data types, remember that division of anything by anything always produces a float as its result. Likewise, this is really just a different kind of division. Some variable to the negative power, a negative power is just division in disguise, really. It's the same thing as 1 over the quantity x to the y. So that also is going to give you back a float. But the results otherwise depend. If you have 2 ints, you get an int. If either one is a float, you get a float. Good? Okay. And then way back in ancient history, believe it or not, this was actually on day 2, not day 1. We have these 5 low-level so-called scalar types, int, float, stir, bool, and none type. And the key things to remember here are that ints in Python are arbitrary precision, which, by the way, is not true in the ND array, right? If you have floating point values in the ND array, they have a more restricted range. Floats are represented in 64-bit double precision, according to an IEEE bit pattern representation. If you if you care about hideous details. Then we have strs and bools. The only valid bool values are true with cap T and false with cap F. And then we have the lone value none, representing nothing. Remember with strings that you have 4 different ways of representing a string literal. You can either use single quotes or you can use double quotes. So you can use single quotes around a string containing double quotes, or double quotes around a string containing single quotes. If you have a string that might contain a mixture of single quotes and double quotes, then you can, pull out the bazooka and use either triple single quotes or triple double quotes to turn off the special meaning of everything in between those pairs of triple quotes. Now, a couple other advantages of or a couple of other things to remember about the triple quote versions are that a triple quoted string can be multiple lines long, which is convenient. And as a corollary to that, triple quotes are a common tool to use if you want to comment out an entire block of code that you're debugging. Okay. There are various special characters like new line and horizontal tab that you represent as a backslash followed by either N or T in the respectively. We talked about the rules for legal variable names. Technically, these are identifier names. The rules for a legal variable name are the same as the rules for a legal function name or the rules for a legal class name. So technically what we're talking about here is the rules for an identifier. You have to have a letter or an underscore as the very first character, and then optionally you can have any number of additional letters, underscores, and decimal digits, that is 0 through 9, in any order that you like. Creating a variable is simply a matter of assigning a value to that variable, and what this actually does is to set up the variable to refer to that object within your Python environment. We also, by the way, introduced things like plus gets, times gets, which are just convenient shorthands. Instead of saying A gets A plus B, you can say A plus gets B, and it means the same thing. Well, so 6 weeks in an hour. Anybody have remaining questions? Yes. The rules for the final will be exactly like for the quizzes. You'll have 80 minutes. It will be open book, open system, open web. You can run the Python development environment of your choice. You just can't communicate with other people during the exam. Yeah, I'll try to get. Yeah, I'll try to get that graded. I'll try to get that graded today. Boy, I'm gonna have a late night. Other question? Yeah.
Is it possible to get without last year questions?
You should assume that what's going to be on your final is very similar to what was on the quizzes. That's my answer. Other question? Yes.
Do we have classes next week?
No, no. Next week is all of the other horrific final exams and whatever else you have going on for your other courses. But I'm not gonna. I don't. I'll probably change my mind and be more cruel to people in the future, but I don't. For this material, my goal is for you to know this material. And I figure you can prove that to me one way or the other in an hour and a half, 80 minutes. I don't see the need to spend 3 hours doing that. But anyway, sorry, I was looking at the wrong person. So no, after Thursday we're done. Yeah. It will be a series of questions. A lot of those questions will involve writing little bits of code, but it will be in Canvas just like the quizzes. You can copy and paste, of course.
Very time-consuming.
So my answer to that is everybody's taking the same test. It is therefore fair by definition. And it is equally time-consuming or not time-consuming for everyone. And also, I don't take points off for indentation issues. So if you, that's a really good question. If I say define foo of x to be return x to the power of 3, you define this function in response to a question, and you copy and paste it, and what gets pasted is def foo x immediately followed by return x3. I know that that's Canvas. So I don't take points off for indentation issues in Canvas. Other questions? Yes? That's what I said, isn't it?
I just wasn't sure if it was quiz 3 or this assignment.
Well, this assignment, I will post the solution so that you can see the solution. My TAs will be grading the homework, and that probably won't happen before the exam. But I will. Yep. I have 3 hours of presentations to listen to this evening, and when I get home around 10 o'clock, I'll start grading quiz 3. Yeah, thank you for reminding me, because I probably would have neglected to do that. Other questions, comments, issues? Okay. Alrighty, well, if you do have any other questions about anything between now and Thursday at 3, send me an email and I'll be happy to respond. And a couple of you who asked me questions that were a little beyond what we covered, do email those questions to me and I will answer them, and I will post the answers as announcements to anybody who's curious. Good? Okay, I'll see you all on Thursday.